In this video, I'm going to show you how you can create this interactive trading dashboard using Plotly Dash. We're going to be streaming real-time candlestick data from the Bitstamp API, which is a well-known crypto exchange that offers free and easy access to its data. We can select from a variety of different timeframes. I've programmed in 3 here, so you can have this as minutely data, so 60 seconds, hourly data, 3,600 seconds, or even daily candles, although obviously these aren't going to move very much as we're requesting updated price data once every second or two. We can also very easily change the pair that we're looking at, so from BTC to ETH or to XRP. And at the bottom here on a separate graph, I've plotted the RSI to show you how you might go about plotting a different indicator or any other metric that you want to show. This could be the P&L of your strategy so far. We'll be working through all of that in the next half an hour or so. I've also programmed in a range slider here, so you can zoom in on just a few of the candles if you wanted to. So for example, we're zooming in from the 7th to the 10th candle here, and that's going to zoom on the bottom chart as well. You can also change the number of bars, so we can ask for 100 bars if you want more zoomed out data. This is all created in pure Python using Dash. There's no messy JavaScript to deal with. It is helpful if you know a tiny bit of HTML and CSS, but I really do just mean a tiny bit in order to get going with this library. If you're not familiar, Dash is created by the same team that made Plotly, which is a very popular plotting library in Python. And it's fast becoming one of the go-to technologies as far as dashboarding goes. When you don't want to leave the confines of Python and have to learn all these other web technologies, Dash makes it super simple and straightforward for us. I'm going to be fetching the data in this video from the Bitstamp API, which, as I said, are a well-known crypto exchange. I'm using Bitstamp because they don't require an API key, and therefore it's very easy for me to show you how to request the data. But you can substitute this with any other exchange that you want data from, say Binance or FTX, or if you have a data subscription service like Polygon, or if you want to pull stock data from your own personal database. It's very much the same ideas behind it, and you'll very easily be able to adapt the template that I'm going to show you in this video to match what you're after. So that's enough rambling from me. Let's dive into some Python and we'll start coding up this dashboard here. I'll start out by closing off this dashboard so it just stops running and we don't get confused, and I'll cancel the other process here. I'll just exit out of that terminal. And I have a fresh Python file prepared here. I've imported some components that we'll be needing throughout the video, just so you don't have to sit here and watch me type out all these different imports. If they don't work for you, just make sure that you install the correct components. So you'll need Plotly, you'll want Dash, you want Dash Bootstrap components. That's going to give us some nice styling. And then Pandas, NumPy, requests to get the data, and Pandas TA to do our RSI calculation. That should be everything you need to get going. I would recommend following along with this tutorial in a regular Python file, not in a notebook. Although it is possible to use a notebook with Dash if you want, a Jupyter notebook, but you have to do some extra configuration, so I'll leave that as an exercise to the reader. In terms of the app itself here, it's fairly straightforward as to how we construct it. So we create this app from this Dash component that we imported over here. And then I'm passing in this dunder name here, which is just going to give us where the file was imported from. I'm not entirely sure if that's required, but we can try deleting it. And it looks like that worked just fine. I think that just gives it a name, but it'll function fine with that one. The next element here is we're setting the layout of the app. So if you know a little bit of HTML, you'll be familiar with a div. A div is essentially just a container for other elements. So currently the entirety of our app is just a single div element, which is why when I looked at it, then if I load it back up again. So if you just click on this link after you press run, it's just completely empty. If I do inspect here and look in the body, we've just got a div, and that seems to be all that's going on, which makes sense because we haven't put anything interesting in here. Okay, let's add some element at least so you can get an idea of how this works. So this is a list here inside the div, you'll note, just a regular Python div. So we can add other regular HTML objects in here. So I could do html.h1, for example. H1 is like a main title, and I can give it some text. I can say, hello world. And if we run that, we should get some nice hello world text. So that's all well and good here. We can have a great variety of fun just adding different HTML elements in here. But fundamentally, we haven't gained anything above using just raw HTML here. It's not anything particularly interesting. So let's add a graph into the mix and think about how we can dynamically update the contents of that graph in real time. So to add a graph object into here, it just comes from this DCC component that we imported at the beginning. So dash core components, I believe that stands for. And we can ask for dcc.graph here. And then you can provide any particular details about that graph. We're going to leave it pretty much empty here. The only thing I'm going to do is I'm going to give it an identifier. So ID equals, and then you can call it whatever you want here. So I'm going to call mine candles because this is eventually going to be the candlestick chart. So let's give this a run and see what it comes up with. So we've got this very nondescript chart here. It's at least a start. It's better than an empty page or just a H1. How do we actually write something to this chart? Well, the way we do that here in Dash is we create a function which returns this graph. So if you're familiar with regular Plotly stuff, just creating regular graphs in Plotly, you'll be familiar with a figure object that you pass around and then you do usually something like a fig.show at the end. What we're going to do is we're going to construct a figure object and we're going to inject it into this space. So we're going to create a regular old Python function and I'll call it update figure. That's what I'm going to call it. We'll just leave it as pass for now. And at this point, we need to tell Plotly how and when to use this function and what this function does. And you do that using a callback here. So a callback is just a fancy decorator. So it's going to modify our function and make sure that it's called at the right time and that kind of thing. And the things we need to specify here is the input and the output. So the input is going to be the trigger for this function. So for example, if I had a drop-down menu like I did on my original chart, if I change one of the elements of that drop-down menu, say I change the trading pair, then you might want to change the candles. You'll want to redraw them with the new trading pair. Same thing would apply for the range slider which we had. So if you select a different range of candles, you'll want to redraw them. Now for the minute here, we don't have any drop downs or anything. So what I'm going to do is I'm just going to say that every 2 seconds, I want you to call this function and therefore update the graph. And that's going to make sure that we're plotting the data in real time. So we're getting close to real-time data here. If your API updates more often than that, if you can get more frequent updates, then feel free to set the interval to a smaller amount. So I'm going to create a component here called interval. It needs an ID like every other component so that we can find it later on. I'm just going to call mine interval. And if you don't set the value of interval here, so interval is going to be the time in milliseconds between activations. I believe it defaults to 1 second. So I'm going to set it to 2000 milliseconds or 2 seconds. So we've got this interval object here. Let's go and feed that in to this callback. So we'll declare an input here. So I imported input right at the top there. That's coming from Dash. We can do input. Then you'll want to select the ID of the object that's going to signal this. So in my case, it's going to be the interval here. So when the interval updates, I want to input something into my function. Now we don't actually need to take in any information here, but I'm just going to take the n intervals. So that's going to be the number of times that the timer has ran. If you're wondering where I pulled that from, there's a documentation page for every single Plotly Dash component, and that will label them all here. So you can see n intervals here, or interval, or max intervals. You can query any of those parameters and insert them into your function here. So this function is going to take in the number of intervals. So I'll just make that a parameter here so that it passes into our function. It's n intervals, not n interval. So what we'll do here is we'll whip up a quick example so that we can put together all these abstract ideas that we've just learned. And we'll create a h1 element up here. So dcc.h1. And this is going to have the ID of countdown, or count up maybe. And I'll set the initial value here to 0. So there's just a regular h1 object, just a regular title. We've set the value to 0, and it's going to count up. Now what I can do is I can add an output here to this function. So I can say output. What do I want to output to? Well, I want to output to the h1 object, and I've called that count up. So I need to put the ID of the object that we want to inject our value into. And then the second element here is which attribute of h1 do I want to put the return value of this function into. So I want to change the value of h1, so I'm going to do value here. It can be a little bit scary, but you get used to it soon enough. So that's the callback created. Now all I have to do is just return the number of intervals, and we'll make sure that it's a string so it can be displayed properly. And that should work for us. Of course, if we don't have any syntax errors hiding. In this library, you're going to be dealing with lots of big lists of things, so it's very easy to forget commas at the end there, like I just did. Dash.dcc has no attribute h1. That's because it comes from HTML. Looks like I used the wrong component here, so you can see it's complaining that I used value. Let's try some of the other ones. So we could try either title, looks promising here, or if not, children. So let's try title. Title and title. And according to this exception here, we must provide all outputs first. So we'll just reorganize those. And we should be actually functional now. If I go ahead and open that up. Looks like that's not showing up here, so let's investigate a little bit more here. Instead of title, we'll change the children attribute. So we'll do nothing in this h1, we'll just leave it blank, and we'll change the children attribute instead. Children. There we go. Now we can see actually counting up. Can be a little bit of trial and error there to find the right attribute, as you've just seen. But if we just think about what's happening here, the interval is running every 2 seconds, as we asked. And it's taking the output of that interval. So we asked for the n intervals, the number of intervals that have happened so far. Every time the interval ticks, that gets passed into this function. And the return value, which is just the number of intervals, gets passed into the count up element. So the element with ID count up. And in particular, we change the children attribute to be equal to whatever we return. Hopefully, that's a straightforward enough example to be getting on with here. What we're now going to do is we're going to take this up a step in complexity, and we're going to change this graph object here to be our dynamically updated candlestick chart. I'll leave this as it is for now, the callback and whatnot, until we're ready to actually set it. So I'll just leave that return statement in there. But we can do the rest of our calculations inside this function. So really, the first thing that we need to do is we need to retrieve our data. As I mentioned before, I'm using the Bitstamp API, which is free for everyone to use, and you don't need an API key or anything. If you just go to bitstamp.net/API, scroll all the way down to open, high, low, close data, this will let us get an updated Bitcoin price every couple of seconds. If you want to get fancy and use a Websocket or something like that for your data source in order to get faster and faster updates, you can of course do that, and much of the logic here will be very similar. So let's paste this URL in here. So we'll create a variable here, we'll call it URL. And for now, we'll just hard code the currency pair. We'll change that later on so that we can select it from a drop-down menu. For now, I'll just hard code it and not worry about that too much. If we go back to the API here, you can see that we can provide a few different parameters here optionally. So you can provide a start and an end time. All I'm going to do is I'm going to provide the step here. So how many seconds we want it to be. So 60 seconds is 1 minute candles, 3600 seconds is 1 hour candles, etc., etc. And then we pass in limit, which is the number of candles that we want. And by default, it will bring the most recent X candles. If you ask for 100 candles, it will bring the most recent 100. So let's fill in those parameters in a parameter dictionary here. So params is equal to a dictionary. We'll pass in the step here. So I'm just going to say 60 seconds for now. We'll pass that as a string. I don't believe it matters too much. And then we'll also pass the limit here. I'm just going to hard code in 30 bars. I don't think that'll harm us in any way. And once we've done that, we can just request our data using the requests library. So you can just do data is equal to requests.get, pass in our URL, and we do params is equal to params. So we set the parameters for this URL equal to these ones here. Let's print that out here and see what we get. So print data. Now remember, this function's still going to run every 2 seconds. Nothing's changed about the callback here, so the function's still going to be invoked in the same way. And that means we should be requesting the last 30 bars of 1 minute price candles for BTC USD every 2 seconds. Let's see what that looks like. So we can see here it's printing out response 200. So if you just print out the data object like I did, it's going to give you the HTML response. 200 means we're all good, so the request was a success. If I then go in here and do a .json on this, .json, and run the whole process again, you can see we now start getting a ton of different open, high, low, close bars here. So you can see this is a list of dictionaries, and each dictionary is 1 bar. So this is the close value, the high value, the low value, etc., etc. And we've got like 30 different bars here. The data that we want to access is inside this list here, and this list is nested within these other 2 dictionaries. So in order to access that, we have to index into data, grab this, and then from within that dictionary, we grab this. So fairly straightforward. We can just do it here. We can do data, open, high, low, close, and that'll grab our data for us. You may want to add a try and accept here, try and accept, because sometimes this request might fail depending on the API that you're using and how reliable it is. For now, I'm just going to leave it as it is. I haven't ever had much trouble with the Bitstamp API before. If we give that a whirl, that should have all our data just as a list of dictionaries right now. And thankfully for us, pandas can create a data frame straight out of a list of dictionaries. So I can do data is equal to pd.dataframe. So I can create a new data frame here, just pass in that data. And now it'll just be way easier to read for us. So rather than having that confusing mess of dictionaries, we've now got a really nice close high, low open data frame here that's significantly easier to read. I'll close down this up here. Sometimes if you leave extra Plotly tabs open, it can run twice at once and that can confuse things. So sometimes it's better to just shut down the windows. One modification I am going to make to the data here is just our regular conversion to date time. So the timestamp that we get here, so if I just go out of here, the timestamp is in seconds since 1st of January 1970. That needs to be converted to a date time object so that Plotly can pick it up and properly draw out open, high, low, close candles. So data.timestamp is equal to pd.to_date time. We pass in the same column there with data.timestamp and we just select the unit is equal to seconds. Great. If I run that, things should look a bit more human readable here if we wait a few seconds. Oftentimes the function won't run unless you have a Plotly window up here. So you can see it wasn't running there and then I opened the Plotly window and it now starts actually running when I open the web browser. So we can see that our time is properly formatted here in UTC. So let's use this to draw out our open, high, low, close candles here. There's a good example for this on the Plotly documentation. You can just copy and paste from there if you don't want to type it out. But it basically goes something like this. So you create a variable, call it whatever you want. This is going to contain the figure for our candles. It's the thing that we're going to inject into that graph object we created earlier. We're going to replace this empty graph with this new variable that we're creating that contains all our candles. So candles is equal to go.figure. Again, we're creating a figure object here. And then the syntax goes data is equal to open square bracket, go.candlestick, open curved brackets. In here, we just put all of our different data. So X is going to be data.timestamp. The open is just going to be data.open. The high is just going to be data.high, etc., etc. here. The low is going to be the data.low, and the close is going to be data.close. Do mind capitalization and that kind of thing. Again, if you're using a different API, they might not be exactly called open, high, low, close. Use whatever the column names are in your Panda series. Let's close on out all of those various brackets of different shapes and sizes that we opened up there. And what we can do now is instead of returning the number of intervals here, we'll return this candles object. So return candles. And instead of outputting into that H1 object, we'll now output into the graph. So I'll change this ID to candles. And instead of accessing the children attribute, we'll access the figure. So I'll change this to figure. And all being well here, we should have our open, high, low, close candles going. There we go. It looks good to me, really. You can zoom in here with this rangefinder. Although what will happen is that we're redrawing this from scratch every 2 seconds. So if you try and zoom in using this feature, it won't quite work with the method that we're doing things here. Although, as you can see, this is updating in real time. If you sit here and watch this for long enough, these candles will move along. The first candle here will move up and down respectively. And so we've already got a real-time candlestick system here, although obviously we need to make this a little bit more fancy. So let's go back to our regular old Python file here. And I'm going to make a few adjustments to the candles object here. So we can do candles.update layout. We'll get rid of that range slider on the x-axis because it's a little bit deceiving as it's just going to zoom you out anyway. So we'll get rid of that x-axis range slider. Visible is equal to false. And we'll also just set the height to be a fixed value. I'll set it to 400 pixels since that's what looked good in the demo earlier. So that should just get rid of the range slider now. Perfect. While we're at it here, we might as well plot the RSI below this. It's not going to be too much extra effort, especially if you know a bit about Plotly. So we'll use pandas TA to calculate the RSI up here after we've got our data. So we'll do data RSI is equal to ta.rsi data.close.as type float. The reason I'm converting to a float here is that by default, if you look at the data types in this data frame, everything's going to be a string. And obviously to do any numerical calculations, things need to be floats or ints or some other kind of numerical value. So I'm just converting all of the close values to float types. Do watch out for that because that might trip you up if it thinks it's a string and it'll get really confused. So that's going to add our RSI column on here. And all we need to do to plot that on out here is go down to the end. We'll create a new graph. So I'm going to call mine indicator. This is going to be the indicator graph. That's going to be px.lines. That's Plotly Express. Again, we imported that at the very beginning. We just provide the x and y values here. So data.timestamp. Y is equal to data.rsi. We'll set a height value so that it doesn't take up too much or too little space. And all we have to do in order to output that is to create another graph object here. So there's one called candles. This one I'll call indicator. And we also need to create another output from this callback function. So instead of outputting to the candles object, we'll output to the indicator object here. You can have multiple of these functions here, these callback functions, to update different parts of your dashboard. And indeed, I'll show you how to do that later on. But in this instance, it makes sense to do them all in one function, as we only want to request this data once and then calculate all of our candles and our RSI values. We don't want to keep spamming the API unnecessarily here. Okay, so our second output here, and it goes from top to bottom. So our first output is the candles and the second one is the indicator. So in our return statement down here, the second return that we do will be the indicator. And that should work fine. If I load this up, there you go. You can see the RSI is calculating here. Obviously, it's only running from this bar. That's because the RSI needs some warm-up bars. As by default, it uses a 14-day window. So I'll just add that in there, just for completeness sake. So we'll just add 14 to this limit here. So we'll do int, and then we'll just add 14 to it. And then after we calculate the RSI, we'll cut off the first 14 values. So data is equal to data.eloc 14 onwards. Depending on your indicator or what type of data you're drawing, you may or may not have to do that. It's just if you need some warm-up bars that you're not actually going to show. And so now, of course, it shows the RSI for the full time period that we're looking for here. So this is great and all, but it's a little bit bland and we don't have really any interactivity. I mean, we can zoom in on here, but it'll just zoom you out when it redraws the candlesticks in a second. So I think the next thing that it would be sensible to add here is a new drop-down menu. Now, the simple and easy way to do that, which we'll do first, is we're just going to use one of those DCC objects that we used up here. So anytime you want to add something new into the layout, any kind of new button or drop-down or anything, it's always going to go inside this list here, so you can generally figure out where you're going to put things. I want my drop-down to go above the graph, so I'm going to put it up here. And what I'm going to do is I'm just going to say dcc.dropdown. I'll call it coin select here. So this is going to select the pair that we're looking at. I'll set the ID to that. So ID is equal to coin select. You'll also want to select the range of possible outcomes that it can have. So at the beginning here, you can just provide a list. So I'm going to say BTC USD, ETH USD, and XRP USD. Obviously, these will differ depending on the API you're using and how you're using it. If I go to Bitstamp here, you can see that's the format it wants them in, so I'm just going to do that for now. You could, of course, do some fancy text formatting if you wanted to, but that's not the point of this tutorial. So we've got our ID, we've got the range of possible values that the user can select. Finally, we'll want to select the default value here. So I'm just going to leave the default as BTC USD. That's going to be what happens when we first load up the graph. It's going to do BTC by default here. So that's great. I can run this if I remember my comma. And it's not going to do anything at the minute. That's going to be the main issue. So we've got this lovely drop down and we can select all these different pairs, but it doesn't actually do anything because we haven't hooked it up to a callback yet. So let's go do that. We'll go back here and we can go down to our callback function here and we'll add a new input. So input, it's coming from the coin select object. And the attribute that we want to pass to our function is just going to be value. So it's going to be whatever value the user selects. Again, if you want to find more information about what attributes each of these DCC objects has, the documentation has that all for you. So there should be one for a drop down here. If I click on that one, you can see all the various values it provides, what you can bring, many examples on there for you to look through. So we come back to our Python file here, and since this new value is getting added in here, we can add that as a parameter to our function. So I'm going to call that the pair, or perhaps the coin pair. So BTC USD, ETH USD, something like that. And all we have to do to add this functionality in here is I'll convert this to an F string. And then we can just substitute it in here. So instead of hard coding BTC USD, we'll just add the coin pair in here. And hopefully when I run this, whenever I change the value in that dropdown, it'll change the pair. So as you can see, this is getting Ethereum data. This is getting XRP data. So I hope you're starting to see the power of Dash here. So we created these lovely looking plots here. And it was very easy to make this dynamic with a dropdown just by adding a new input to our callback function. And of course, the timer will continue to run here. And whenever the timer runs, this chart will update, which is every 2 seconds. And we'll be plotting new fresh data on here. Let's add in the other components here so we can get this dashboard fully functional. So we'll go back. And we'll add another couple of drop downs here. So the first one is going to be the time frame that we want. Now again, on the Bitstamp API, the way we do that is we just ask for the number of seconds that we want. So 60 seconds is 1 minute, 3600 seconds is an hour, and then 86,400 is going to be 1 day's worth. We'll just change the ID here. So that's going to be the time frame select. And the default value I'll set to 60 here. We'll then add another drop down, and that's going to be the number of bars that you want. So I'll set mine to 20, 50, and 100. And this will be the number of bars. So num bars select. Those are our 2 new drop down objects here. I'll change the default value here to 20. And as before, we need to add those as inputs to this function so that whenever any of these values changes in the dropdown, it makes sure that the candlestick graph is redrawn. So we'll just go down here, we'll copy this input, and we'll ask for time frame select. And the same thing here, it's just the number of bars. They're all the same type of object here. They're all drop downs, so we just want the value from them. And we can add those as new parameters here. So we've got time frame, and we've got the number of bars. Easy enough to integrate those into what we've already got here. So the step is just going to be replaced with the value of time frame. And this 30 here that I hard coded in, well, that's just going to get replaced with the number of bars. So if I run this, we should now see that all of our drop downs work. So if I select the 50 bar option here or the 100 bar option, again, I can look for 1 hour data or ETH data or XRP data. This is nearly fully functional at this point. The only widget here that we need to add on is a range slider. So let's go ahead and add one of those. As you might expect, Dash already has one of these built in for us, so it's just a simple case of asking for a DCC component here. So you can do DCC.range slider. Provide a minimum and maximum value along with the step. So this will go from 0 to 20 in steps of 1. You can provide the initial value here for the selection. So we're going to select from 0 to 20, so the full range. The ID, well, we're going to call that range slider, simple enough. And that should create our range slider for us here. What we then have to do is say every time we update the value of this range slider, so say we only select the first 5 bars, well, we want that to now redraw the candlestick chart again. So same as usual, we just go over here and we grab the range slider. And every time the value changes, that being the range of values that we've selected, we want to redraw this graph. So I'll put that in here as range values. And it'll pass that to us as a list here. So it'll be in this format here. So it'll be a list with 2 entries. The first element is the start of the range. The last element is the end of the range. To implement that, all I'm going to do is go over here after we've trimmed our data down. So after we got rid of those warm-up bars, I'll come in here and I'll do data is equal to data.eloc. Then we need the first range value. So range values 0. And we'll slice until the final range values. So range values 1. And that should work for us. So if we run this again, boot up our chart, you can see we've got a range here. If I drag that along, that is slowly cutting off all of the bars here. So now we've got the most recent 4 bars, 3 bars, 2 bars, the most recent bar, if that's all you want to look at for some reason, and the current RSI value, although it doesn't really show very well because there's only 1 point on the line. One problem that we have here is if I select a larger number here, so say I select I want 50 bars, the range slider doesn't change. So I can actually only select the first 20 elements. This is a bit of a problem for us, so how are we gonna circumnavigate this? The solution I came up with here is that we create a new range slider object every time this value changes, and we inject that new object into this slot. That might sound a bit complicated, but easy enough once you get the hang of it. So we'll dive on in here. And what I'll do is I'll take our initial range slider here and I'll wrap it up inside a div. So just a regular old HTML div. This is going to contain the range slider. And for now, the range slider itself doesn't actually have to change. We'll just give the div here its own ID and we'll call it range slider container. And its only job is to contain the range slider. We're perfectly happy with the range slider as it is, as long as we keep the number of bars at the default value. And so this is fine. What we can do here is we can create a callback function which triggers whenever we change the number of bars. And whenever we change the number of bars, we'll create a new range slider object to replace this one with the range of values that we want. So we'll go down here and we'll make a new callback. So we'll do app.callback. The output here is going to be into this div. So we're going to go into this div, and this list represents the items that are within the div, called its children. And we're going to replace those children with our return value. So this is range slider container. And we want to replace the children. So we want to just replace that list, basically. When do we fire this function? Well, we fire it whenever the value of the number of bars select changes. So input num bars select, and whenever the value changes, that's what we want. Okay, let's close out the callback here, and we'll create our function. So I'll call it update range slider. It'll take in the number of bars, that's our input value, remember? And then all we're going to do is we're just going to return a new range slider. So we're going to create a new range slider and insert it in the place of the old one. So the min value is just going to be 0. The maximum value, well, that's just going to be the number of bars here. So however many bars we have, we want that to be the end of the range slider. The step, well, you can leave that 1 if you want, but the slider is going to get very crowded. So what I did is I divided the number of bars by 20, and then I rounded that to the nearest whole number, and that's what I use as the step value. So there'll always be 20 different chunks in the range slider. I found that that looked quite nice aesthetically, but if you have a different need, you can change this. So we'll round to a whole number, the result of dividing the number of bars by 20. You have to do a lot of conversion to integers here because I believe these input values get passed in as strings. Then you provide the initial value in here. So value is equal to 0 to the number of bars here. So just whatever the max value is, that's what we want the initial range to be. So we get all of the data. And then finally here, we want to preserve the same ID here. So the same ID as the range slider we had before. So ID is equal to range slider. And what that's going to do is it makes sure that whenever we update this range slider object, whenever we change its value, it'll still run the other callback where we updated the candlesticks. So if I let this run and I get my syntax right, I believe I lost another comma. Then what should happen is as we change this to 50, a new range slider here gets returned. And now we can use this new range slider, which goes up in 2s, or if we go all the way to 100, the range slider now goes up in 5s, and we can select a random region of 5 bars, and that all seems to be functioning well. So as far as functionality goes, I think that's pretty much everything I have to show you today. The rest of the tutorial, we're just going to focus on styling and making the dashboard look a bit nicer, a bit more like the one I showed at the beginning. Obviously, this is a little bit horrendous to look at and nothing's labeled properly, so we'll need to be fixing that. But as far as the fundamentals of Plotly, you have basically everything you need to know here. I am going to use a little bit of CSS in what is to come. You'll probably want to get at least a little bit familiar with CSS if you're going to be working with Dash a lot, as it comes in handy quite often. So the first thing I'm going to tackle here, just to show you how it works, is the styling on this range slider here. So it's very, very close to this drop-down bar here. I don't particularly like that. And it's also too wide. We don't really need it to fill up the entire screen here. So to change that, I can just add some inline styling on the div which contains it here. So this div remains constant, although we do update its children. So what we can do is we can just add some inline CSS styling. So we can do style is equal to, and then we can add whatever we want in here. So I'm going to specify a width of 800 pixels. I'll tell it to automatically sort out the margin. And what that's going to do is make sure it's centered horizontally. And I'll also add some padding to the top of 30 pixels. And that'll make sure it doesn't get too close to the other buttons that we have above. So this is just regular old CSS. You can write it in line like this. I'm sure there's maybe a nicer way to bundle this together, but for what we need here, inline CSS works just great. So I'll show you this just to show that it actually works here. And you can see that the styling of our slider has changed here. It's now smaller, only 800 pixels wide, and we've got that space on the top there. Let's sort out these drop downs now because they really are quite horrifically ugly the way they are at the moment. So the way I'm going to solve this is I'm going to create a function here. So the function is going to go up here. And the function's going to create a drop-down element, or my version of a drop-down element, which has both the drop-down and a title that tells you what it is, all encompassed in a nice div. So to do that, I'll create a function here called create_drop_down. It's going to take in two different parameters here. It's going to take the options that we want for the drawdown, and then it's going to take the ID here. So whatever we want to set as the ID, and whatever we want the options of the dropdown to be, it'll pass those into here. And it'll derive the title or the label it should put on the dropdown from whatever the ID we pass in here. So we'll open up this function, and all it's going to do is it's going to return a div here. So a div, we open up these square brackets here, so we access the children. And inside this div, inside this container, I want to put the title of the dropdown and the dropdown. So the title, I'm just going to write as a h2. So html.h2 here. And for now, I'll just put in the ID in here. So it's not too complicated for us initially, but we'll neaten that up in a second. And then the second element, I want to create the dropdown. So dcc.dropdown, same as before. We'll add in the options. The ID is just going to be whatever we set this ID value to be. The default value, I'll just set that to the first item in this list that we pass in, the list of possible options. And that should be good. Again, it'll probably look quite horrific. It won't have much styling, but it will actually function, and it'll show you this cool feature here we have in Dash where we can create nested components and then display those quite easily from within our main div here. So instead of doing dcc.dropdown, I'm now going to call create_dropdown. So create_dropdown. I'm going to do that for all three of them here. And I'm also going to alter the arguments here. So I'm going to get rid of value here. We don't need that anymore. And I'll just make sure all the arguments are named correctly here. So there we go. Let's see what that looks like. It looks like options is not defined. I named it wrong. It's called options. If we come up here, there we go. So this is looking slightly better now. We've got something a bit more reasonable. We've got a title above each of them, and they're laid out a bit more nicely. But we don't really need them to take up the whole width of the page here. They're only showing very small amounts of characters, like 6 characters for the pair here. And so what we can do is we can put all of these elements inside a div and then style that div using Flexbox. Now, I'm no Flexbox master, but there are a few easy styling controls I can show you here to make it look a lot nicer. So these elements are going to be contained within the div. They're going to be the children elements. And then we'll add a inline style here. So style is equal to, well, we'll set display is equal to flex. So that will start the Flexbox. If you haven't used Flexbox before, just Google it. There are plenty of good tutorials on it. What it's going to allow us to do is to neatly organize these 3 different components into their own separate boxes. So I'm going to set margin here equal to auto. So the same trick I used before with the range slider. I'm going to use the margin auto here to make sure everything's centered. I'll set a straight up hard-coded width here. We're not too interested in this working on mobile or other platforms. We're just going to be using this, say, as our own personal dashboard on a web browser. And then finally, I'll set justify content here. And that's going to be space around with a dash in the middle there. I'll close out the style there. Make sure I add my comma. And that should be good here. If I run this, let's go over here. There we go. You can see they're a bit crammed together here, which is not ideal, although at least they're not taking up the full width here, which is progress. Let's go back and check that I spelt everything correctly here. Yes, I spelt justify wrong here. So if I open this now, they're now nicely spaced apart from each other, which is great for us. One final bit of styling that I'll do on these drop downs is just to get rid of this dash here. And we'll also get rid of the select here. That way it just looks a little bit nicer. So to do that is just as simple as editing this ID value here. So I'll just do a dot replace any dashes with empty space, or rather a full space, since we want a space between each word. And that should be good for now if we test that. There we go. You can see it got rid of the dashes there. To get rid of these selects here, I'll use a little trick. So I'll just do split on all spaces like that. I'll select all elements, but the last one here. So we'll slice to -1, and then I'll join them all together again. It's a little bit hacky, but it works. So it's empty space, dot join, the list here, selecting all but the last value, which is select. So that should work. There we go. We can select the coin, the time frame, and the number of bars. Now the coin here, we can see it's a little bit squashed. So in order to add some padding in here so that this will have more space, we can do that with a little bit of inline styling again. So we'll go back to this H2 object and the drop-down objects. We might just be able to add some styling in here. Let's see if that works. So inside the div here, we'll give that some padding. And we'll assign the padding all the way around here. So I think this is 0 on the top, 20 on the right, 0 on the bottom, and 20 on the left again. That should just give the box a little bit more room to breathe here so it can display its contents. Let's see what that looks like. That almost seems like it worked. Let's apply it to the title. Let's just copy and paste this and see if it works there. Often the case with CSS in my experience. You have to do a little bit of trial and error now and then. So we'll set the styling on the H2 like that and see what that looks like. That looks like it's just about working. Maybe we'll add a little bit more padding in there. We'll add 30 pixels. And we'll bump this up to 30 as well, see if that works. There we go. So that's enough padding, and now you can easily select the different pairs here. And that's all working fine. The final thing I'll do here is we'll add an external style sheet in here. So I'll close all these other tabs, just so that we can change the default color scheme. So using our Dash Bootstrap components module that we installed earlier, you can install Bootstrap themes. So I guess I just found this on bootswatch.com. So you should just be able to link to any of these different themes here just by specifying the name. So we'll go back to Cyborg here, just because it looks a bit better with the dark theme. Come over here, and when we create the Dash app here, all you have to do is do external style sheets is equal to dash bootstrap components dot themes dot cyborg. Make sure that's all capitalized there. And that should style at least some of what we've got going on here. It won't style the graphs for us, or at least I can't figure out how to make it style the graphs easily. Thankfully, Plotly itself has some built-in styles that we can very easily apply to the graphs here. So I can come all the way down to our first callback function. And whenever we create a graph here, we can just add a theme to it. Now, there are plenty of them that come with Plotly. You can find them very easily using Google. I'm going to add one to our indicator here. So template is equal to Plotly dark. And I'll do a similar thing for the candlestick. I don't think you can insert it directly in the instantiation of it here. It's generally best, or at least from what I've seen, to update it in this update layout here. So you can now select a template, and I'll just set that equal to plots. Play dark again. Looks like we're running out of characters there. So that's how you change the styling to look a bit nicer. Now everything's got a nice dark theme for us. The size of the text seems to have radically changed due to our new style sheet here. So maybe we can just override that and make it look a bit nicer. So I believe we should just be able to go up here to our H2, change the text size to something smaller, like 20 pixels, or let's just say to 15 pixels. See if that works. Nope. Well, let's go for the quick and dirty fix of changing this to maybe a H4. There you go. One final thing I'm going to do here is I'm going to add a attribute to each of these plots so that they update a bit more smoothly. You can see it's kind of jerky. It jumps up and down quite a lot. You might like that or prefer that as a style, but you can also apply a transition time on it. So if we go down here, right again to our first callback function, we can update the layout for both of these graphs here. So update layout. We can add a transition duration in here. So transition duration. And this works for most plots. And what it attempts to do is smoothly transition the graph over a certain period of time. So we'll run this on indicator. And if we watch it for a few seconds here, the graph should move a bit more gracefully than before. It shouldn't jump up and down too much. We'll just watch it here for a second or two. It's especially visible on the RSI graph here. The candle still seems a bit jumpy to me. But regardless, that's all I've got to show you in this video. You can expand on this in a million different ways to use it for your own purposes. And more importantly, if you stuck all the way through this tutorial, you've learned the foundational concepts of Dash. And so you're free to integrate any of Plotly's super advanced plotting APIs. You can draw heat maps, scatter graphs, line graphs, candlestick charts, all super easily, all purely in Python without having to touch any scary JavaScript or much CSS at all. Another idea to extend this project would be to use something like a WebSocket for real-time data, like the one provided by Binance, which I have a tutorial on. I'll leave that in the description if you fancy integrating that into here. And so I hope you enjoyed the project and that you learned a lot, and I'll see you in the next video.